Next, we're going to talk about symmetry. Now, I know symmetry is a concept that you are very familiar with, so this first part is going to be very easy. We're going to find ways to test algebraically for symmetry, so that way if I just give you an equation, you should be able to test, does it have x-axis, y-axis, and origin symmetry? So we'll get to that. So graphs can have symmetry basically one of three ways, or they may not have any symmetry, that's fine too. But there is x-axis symmetry, and that is where your line of symmetry is the x-axis. Y-axis symmetry means that your line of symmetry is the y-axis. These are shockingly obvious terms, I know. Origin symmetry. I know you talked about this when you did transformations like back in geometry, but you may have forgotten. Origin symmetry means it's symmetric about the origin. What this looks like is it looks like a rotation. Do you see how that's rotated 180 degrees? Okay, so these will look like a rotation of 180 degrees, but we call that origin symmetry. Now, obviously, if you're looking at the graph, it's obvious if they have x, y, or origin symmetry, but we can also find these algebraically, and that's a really helpful tool when you don't have the graph, when you want to create the graph. So, if it's symmetric with respect to the x-axis, that means, I'm going to draw this for you. Okay, so let's say we have x-axis symmetry. So whatever this graph is, it's symmetric across here. So that means if we have some point, x, y, that means that point is reflected down here at x, negative y. Okay, so using that definition, we can test. We can test to see if something has x-axis symmetry. So that's right here in green. If you want to test, you replace y with negative y. Okay, so if you're testing for x-axis, replace the other variable, the y. Replace y with negative y, and then see if you get an equivalent equation. We'll do an example of that, don't worry. All right, now if you're symmetric with respect to the y-axis, so here's kind of what this looks like. Your line of symmetry is the y-axis. So that means if you've got a point over here, x, y, it's going to be reflected over here at the point negative x, y. Which means if you want to test for y-axis symmetry, you replace the x with negative x and do a little bit of algebra and see if you get something that's equivalent. Okay, so to test for y-axis, replace the x. Okay, so they're opposites of each other. Okay, origin symmetry. So if you are symmetric with respect to the origin, okay, that means this is that rotation one. So we've got this point over here, x, y. Origin symmetry means it's rotated 180 degrees, so that means it's somewhere over here, that sound effect. And this is the point negative x, negative y. Okay, so if you're going to test for origin symmetry, you replace the x with negative x and the y with negative y, and you see if you get something equivalent. There are several of these on your homework. I can tell you on the tests that we do over Chapter 1, you're going to have to show the work for these symmetry tests. So make sure you follow along and know what's happening here. So we have this function, y squared equals 6 minus x. We're going to test it for symmetry. We're going to test x-axis, y-axis, and origin. So there's 3 steps to this. So first, we're going to check for x-axis. To check for x-axis symmetry, we plug in negative y. So we do negative y squared equals 6 minus x. Now, we're going to simplify this. What is negative y squared? Well, that's just y squared. Because the negative y times negative y, the negatives are going to cancel. Now, do you see that this is the same thing as that? Exactly the same thing? So this is a yes. This thing has x-axis symmetry. Great work. Okay, now we want to test for y-axis symmetry. So to test for y-axis symmetry, we take our original function and we plug in negative x. So we have y squared equals 6 minus negative x. And then we're just going to simplify this. Y squared equals 6, negative negative is plus 6. And you compare that to the original. Is that the same thing? because one of them is y squared equals 6 minus x, the other one's y squared equals 6 plus x, not the same thing. So this is symmetric about x-axis, but not about y. Now we're going to test for origin. When we test for origin, we plug in both negative x and negative y. So we're going to do negative y squared equals 6 minus negative x. And we're going to clean that up. Negative y squared is just y squared, and negative negative makes it plus x. And then we compare. Is that the same thing? Well, the answer is no. Okay? So like I said, on your homework, this is what I need to see. I need to see the work for all three of these so that you know. And now the benefit of doing this is now we know it has x-axis symmetry. So when we go to graph it, we can use that to make our graphing easier. Now, there's a little note here in yellow that you can check with Desmos, which I definitely want to do. Hopefully you've used Desmos in the past. It's just www.desmos.com, but it'll graph these things for you. So y squared equals 6 minus x. And there it is. And it's a parabola, but it's on its side. And sure enough, it is symmetric about the x-axis. So you can always check things on Desmos if you don't have a graphing calculator. I think Desmos is easier than graphing calculators anyway. Okay. We're going to do another test for symmetry, and then we're going to sketch it. So, let's start with x-axis. So to test for x-axis, we plug in negative y. So negative y equals x squared minus 4. Well, that's obviously not the same thing. If you really wanted, you could divide both sides by negative 1. Get y squared equals negative x squared plus 4. But when you compare that to your original, obviously that is not the same thing. So that's going to be a no. Y-axis symmetry. Okay, so if you're checking for y-axis, you have to plug in negative x. So y equals negative x squared minus 4. Negative x squared, those negatives are going to cancel, so x squared minus 4. And that's the same thing as what we started with. So we are a yes for y-axis symmetry. And for origin, you're plugging in both negative x and negative y. So negative y equals negative x squared minus 4. Just clean that up a little bit. X squared minus 4. And again, this is just like the first one. If you want to divide everything by negative 1, you can. But you can probably see it the step before. That is obviously not the same thing as what we started. So that's a no. So this just has y-axis symmetry. So the benefit to this is when we go to create our table of values, we only have to plug in positive numbers because then we can just reflect them. We know that this thing is symmetric about the y-axis. So I'm going to plug in 0, 1, and 2. So when I plug in 0, I get negative 4. When I plug in 1, I get negative 3. And when I plug in 2, I get 0. So 0, negative 4, 1, negative 3, and 2, 0. Now we can reflect all of those points across our line of symmetry. And there's our graph. Now I know that was a really simple one. Some of you probably looked at the equation immediately and said that's a parabola. I know that, but when we get into more complicated functions, this will be very handy.